I think you're going to find today very familiar because we've been doing this, these operations. We're just now introducing some additional vocabulary, but basically, you're not going to see much that's new today. We just are presenting things a little bit differently, but you're going to find everything familiar, I think. So we talked about component form. Component form with those angled brackets basically tells you how far you're going to be moving and in which direction from your starting point to your ending point, and also it tells you which direction to draw your arrow. So your A is your horizontal component. Think of it as your displacements. That's just how much progress you've made from your starting to ending point. So horizontal component, and then your B is your vertical component or your vertical displacement. Okay, so draw the following vectors. So wherever our starting point is, we can just go to the right, 2, and up 4, and draw our arrow, right? So an easy starting point is just the origin. So it doesn't have to start at the origin, but it just makes it easier to count, right? So here we'll go over 2 units and up 4. Left 3, up 1. And you're always drawing an arrow towards the direction of your second number. Or sorry, to the in the direction that you've second point, right? So whatever second point you put down, that's where your arrow is headed towards. So left 5, down 5. Know that our vector is going to be pointing in that third quadrant. Over 2, down 10. Okay, next up, find the component form for vector CD. Now, we could graph these 2 points and then draw an arrow towards it, which is fine, right? If we did that, we can just count over 2, up 4 from those 2 order pairs. But we can also do this algebraically. So I want to show you what we can do with that. So algebraically, it looks like this. So anytime I am given a starting point and an ending point, I can do x2 minus x1. That's going to tell me how far I'm going to travel horizontally. And then y2 minus y1, that's going to tell me how far up and in which direction. So x2 minus x1, 9 minus 7. Y2 minus y1, y minus 1 minus -3. It's a little faster than having to graph everything, especially if your order pairs are really far apart, just to be able to use this to get to your component form. Okay, operations with vectors. If I want to add two vectors together in component form, then I'm just going to be pairing their horizontals together and their verticals together. So if my vector u is a comma b, and my vector v is a2 b2, then if I want to add two vectors together, I'll add the horizontals together and add the verticals together. So I'm just matching the like terms basically. Okay. And if I'm subtracting vectors, then I'll subtract the horizontal components, subtract the vertical components, and that is my new component form. And if I have a constant that is in front or coefficient in front of my vector, I can just distribute that coefficient through my vector. So if it was like 3u, then it'll be 3a, 3b. So just like distributing how you would expect distributing with a coefficient. I put it down. So yours.
Thanks.
Okay, so next up, it says perform the indicated operations. Vector u plus vector v. So how would you combine those numbers together?
A1 plus A2 would be
Yep, so -4 goes with what? 2, yep, and then the 1 goes with 5, yep. So that you'll still keep it in component form, but then your x's will be put together and your y's will be, or your b's will be put together. What do we have to be careful about if we're subtracting vectors? Yeah, we got to keep track of this additional negative. You know, if there were negatives within the vector, we have to keep track of the fact that there's an additional negative. So we don't want to, yeah, we don't want to lose track of that additional negative that's outside the two vectors. So try that. So it means I'm going to be subtracting the horizontal components and then subtracting the vertical components. Okay, so negative, so vector will be -6, -4. Okay, next up, 2u, vector 2u minus v. What would you do first?
2u part.
Yeah, let's distribute that 2 through vector u first, and then whatever we get from there, we'll just subtract the remaining vectors.
So mine's parentheses and if it's like
Yeah, so the way I did it was I just did minus vector and I just kept track of them. I don't, yeah. So I did -8 minus 2 and then 2 minus 5.
okay, so you don't do distributed negative.
You do, yeah, you do distribute it in -3. Because 2 minus 5, right? So that's -3. So the negative is associated with that.
My bad. For a second I thought you like distribute to make it like -2 and -5 and you subtract the minus.
Well, then you're adding another negative. Well, here's something that you could do. If you did -8, 2. If you want to distribute the negative through, you can. But then if you distribute the negative, that means you took care of the negative and now you're adding.
Oh, so it's like the same result.
Yeah, it should be the same result, right? But we don't want to do a minus a negative because then we're changing it up. So you really want to distribute a negative 3, you can't, but you got to change that to a plus then. Okay, next up. What would you do first?
Minus 3.
Yeah, let's take care of this negative 3u. And then take care of the 4v. And then you can subtract your results. Or, like Connor said, you could distribute a negative 4 through. But if you do that, you got to do this plus this. But for me, I like to leave that negative there and wait till the end to distribute. But it's up to you. So if I distribute the negative 3 through my vector u, I get negative 3 times negative 4, that's positive 12. And then negative 3 is 1, it's negative 3. So there is the result of my negative 3u. I just took care of the 4 for the second one, so 4v. So 4 times 2 is 8, 4 times 5 is 20. And I just left that negative there and decided that I was going to wait till the end to finish it off. So 12 minus 8 is 4, negative 3 minus 20 is negative 23. Questions there? So first semester, we talked about unit circle, right? Unit circle is a circle with a unit of 1. So in the same sense, we're using the word unit in the same way. A unit vector is a vector with a magnitude of 1. So we have a special notation for a unit vector that is moving in the positive horizontal direction, which is I. And then J represents a unit vector that is moving in the positive Y direction. Okay, so if I want to do a linear combination of unit vectors, we just take our vector and then we just do AI plus B times J. So basically, it allows us to get that component form as the sum of 2 vectors. So for instance, if I want to get this component form in this unit vector form, then I say negative 3i plus 8j. They mean the same thing, it's just sometimes it allows us to work in different ways with these vectors. Vectors 0, negative 5 as a linear combination would be 0i minus 5j, and then we can leave that 0 out since it goes away, so it's just negative 5j. For the next example, it says find the vector with an initial point x and terminal point y as a sum of unit vectors. So the first thing you do is just ignore the fact that it's a unit vector, just try to get into component form. The component form, we always do the terminal point minus initial point. All right, so -2 minus 5, and then 6 minus 5. Make sure that we always subtract in that direction. Okay. Your ending point minus your initial point. So -2 minus 5 and 6 minus 5, which gives us component form of -7, 1. And then converting that to unit vectors, I just say -7i plus 1j. So the vectors drop out, you replace a plus sign in between, and you put I for the first and j for the second. Okay, any questions? All right, we're just gonna do classwork on page 13. But I'm not gonna have you guys do all of them. I just want you guys to do enough where you feel comfortable with the process. So 1, 3, 5, 11, 13, 15, and then 29, 31, 33. Okay. And I'll put the answers up after you guys had a chance to try them, and it should go, you should find this relatively easy. Again, 1, 3, 5, 11, 13, 15, 29, 31, 33. Make sure you're following the correct formula to get to your component forms. check your answers on the board once you have a chance to try them. So I'll put you guys for phone for 5 minutes. You guys are, some of you guys are not. It's a little bit. But then each one. After this. After the first one. The second. Do the same thing, let's take those along. Stay here. I want to figure out how to hold. And then the next month, we figure out. Always start to very focus on this topic.
Thank you for
For 29 to 31, just treat it like all the previous problems. You just, at the very end, you will just include the unit vectors and a plus sign if you want.